Today we are going to take a look at the properties of midsegments. And just a reminder, first thing we're going to do here is we're going to define what a midsegment actually is. So a midsegment, well, it's a segment, obviously, that goes from the midpoint of one side of the triangle to the midpoint of the other side. So a midsegment goes from midpoint to midpoint. Kind of makes sense. And the midsegment breaks the side of the triangle into two equal parts. Okay, so what we have drawn here in this diagram right below here is we've got a triangle, obviously, and that little yellow triangle on the inside is actually the midsegments. So point D is a midpoint on side AB, which means a midpoint means that these two sides are the same, or those two portions of the side are the same. And E is another midpoint, so DE is a mid-segment. And that means also that these two parts are also the same. So there's a mid-segment in red, and then from here to here, that's also a mid-segment, and here to here is also a midsegment. And there's some properties that we're going to use with midsegments. One of them is that the midsegment, so that red line, the midsegment, is parallel to the third side of the triangle. So what that means, okay, is if I have, this is DE is the midsegment that I'm talking about for right now. So let's look at midsegment DE. DE is parallel to the third side. The third side being the one that the midsegment doesn't intersect. So DE would be parallel to BC. And similarly, DF, this here, DF, that midsegment, would be parallel to side AC. And finally, in blue here, we would have midsegment EF, oops, daisies, EF here would be parallel to AB. So EF would be parallel to AB. Okay, that's one of the properties, is about being parallel. And then the other property is that the side of the triangle, so the side of the triangle is 2 times the length of the midsegment. So what that looks like is if you take 2 times the midsegment, okay, it will equal the triangle side. Okay, so no matter if it's an algebraic equation or expression, or whatever it happens to be, just numbers, it's always going to take 2 midsegments to make one of the sides. So let's take a look at that. Okay, these are going to be very simple ones, right? If we look, 26 here, BC is 26. It's a side, and it takes 2 of the midsegments. So this guy here is the midsegment. And this guy here, the other blue, is the side. So it takes 2 of the midsegments to make the side. So that means if the side is 26, the midsegment is half that, which is going to be 13. And then as far as being parallel, DE is parallel to BC. Okay, this one, the DE, this is our midsegment because it goes midpoint to midpoint. And this is our side. And it takes 2 of the midsegments to make the side, so it would be double the length of the midsegment, so 5 times 2 would be 10, and AB would be parallel to DE. Okay, and then down here, right, we've got, this is the midsegment, right, that's our midsegment. Okay, now we don't care anything about the other side. We don't really have any information about the midsegment or the side of the triangle, but we do know that the midpoint, or the midsegment, goes from midpoint to midpoint, which means if it goes midpoint to midpoint, that would mean if this is 6, this is also 6. Okay, so, and then DE, what I have in blue here, DE, the midsegment would be parallel to AB. And then the last one, again, this is the side of the triangle. Point E is the midpoint. Okay, so if this is 8, this is also going to be 8. And AC, that's this guy here, is parallel to DE. Okay, so you just have to pay attention. If it's going to be on the side, that means they're going to be equal because they're midpoints. If it's mid-segment going through the triangle, then it's going to be double or half. And then last but not least, of course, we have to do a little bit of algebra with it. And again, up here, it tells us that 2 times the midsegment equals the triangle side. So once again, here is our midsegment in blue. That's our midsegment. And this is our side. Okay, our midsegment is x plus 15. Our side is x plus 23. So 2 times our midsegment, which is x plus 15, is going to equal the side, which is x plus 23. And then we just have to distribute and solve for x. So if we distribute, we would get 2x plus 30 equals x, oops, daisies, equals x plus 23. Okay, and I'm going to get my x's on the same side, so I'm going to subtract x from both sides. I would have x plus 30 equals 23, subtract 30, and we would get x equals negative 7. So x equals negative 7. Okay, it also asks LM is parallel to what segment? LM is parallel to FH, midsegment in the side. LM, right? LM is our midsegment, and LM is x plus 15. Well, we know that x is negative 7, so we'd have negative 7 plus 15, which is 8. Okay, FH is x plus 23. So instead of x, we're going to put negative 7 plus 23, which is 16, which makes sense because it takes 2 of our midsegments to equal our side. Okay, and then let's just look at one more here. Okay, this one's just turned a little bit on its side, it looks like. So we have LJ. Okay, LJ is here. This again is the side of our triangle, and GF is our midsegment, and LJ is parallel to FG, and it takes 2 times the midsegment, which is 2x plus 32, to equal the side, which is x plus 28. And then we just distribute. We would get 4x plus 64 equals x plus 28. I'm going to subtract x from both sides. 3x plus 64 equals 28. Subtract 64, just following all of our steps for solving. And we get that 3x equals negative 36, and x equals negative 12. So we know x equals negative 12, and then we're just going to go back and substitute in, okay, JL, that's our side, JL is going to be, is x plus 28, so that would be negative 12 plus 28, which is 16, okay, and then FG is 2x plus 32, so we would have 2 times negative 12 plus 32, which would be negative 24 plus 32, which equals 8. And again, that makes sense because it takes 2 of our midsegments. 8 times 2 is 16, so we can kind of check and make sure that we are correct. So that is the main idea that we have with midsegments. So Good luck with that, and there is a class kick that you can work on.